In this presentation, I'm going to present an interactive training resource that I've been developing for a while now, entitled White Matter Segmentation Education, or WMSE for short. But before we begin looking at this resource, I'd like for us to consider why an interactive guide like this might be useful for the topic of digital white matter segmentation. In recent years, the utility of diffusion imaging and tractography has been demonstrated with investigations of behavioral associations, neurological disorders, and neurostimulation. Despite, or maybe even because of this increasing profile, a number of recent papers have commented on the pervasive obscurity surrounding methods in the field of white matter segmentation. This may be due to the range of bespoke approaches that arise from the apprenticeship style of training that is common in our niche field. Thus, one method to address this would be to develop training resources that can be accessed outside of this conventional training pipeline. Moreover, in order to ensure the accessibility and approachability, and thereby maximize the number of potential users, it would be best for such resources to assume as little as possible about the experiential background of the users. This is precisely the approach taken by WMSE. So now that we have an idea of where WMSE is coming from, let's take a look at how it sets out to accomplish this. WMSE is divided into 17 distinct notebook chapters, spanning all the way from a basic introductory overview to the in-notebook performance of an anatomically guided segmentation. As noted earlier, though, one of our goals in developing this resource was to assume as little as possible about the experiential background of our potential users. Because of this, we spend a good deal of time building foundational intuitions from concepts and examples that are far more conventional than brain imaging-derived data. In fact, we don't even really start discussing or working with tractography until about halfway through the lesson set. Instead, WMSE actually begins with a consideration of two-dimensional digital images, like JPEGs. It uses these as examples of digital data objects, and shows, interactively, how the data in these can be used to perform operations like image alignment, masking, and region of interest selection or extraction. These operations, of course, are fundamental tools when performing an anatomically informed tractography segmentation. However, by practicing these in a modality that users are likely to have encountered before, two-dimensional satellite images and maps, we build analogical intuitions that can be extended beyond this relatively familiar context. With this grounding in place, users can more confidently wade into the world of neuroimaging-derived data. Having graduated from the world of pixels, users next move into the world of voxels and streamlines. In this transition section, the elementary data components of neuroimaging and tractography are gradually introduced across several chapters. With these neuroinformatic intuitions in place, we can move on to the real workhorses of white matter segmentation, regions of interest, also known as ROIs. ROIs are introduced in these latter chapters both as data objects and fundamentally familiar tools. We learn how to form them, place them, and move them, as well as the various shapes they can take. We also learn how they can be leveraged to perform increasingly elaborate and complex operations. Finally, in the last chapters of WMSE, we walk through example anatomically guided segmentations of two major white matter structures, the inferior occipital fasciculus and the uncinate fasciculus. These chapters demonstrate the fusion of anatomical knowledge and computational tooling used to perform a digital white matter segmentation, and proceed in a step-by-step fashion, detailing the method and rationale for what is being done. While WMSE is already a fairly substantial resource in its current state, it is, of course, a work in progress. Our current developmental roadmap includes both the polishing of existing chapters and the addition of subsequent special topics chapters. We're also extremely interested in engaging others and the neuroimaging community more broadly in the expansion and development of this resource. Please feel free to reach out to us with any comments, questions, or suggestions that you may have. With that, we'd like to thank our collaborators and supporters, and you for your time and attention.